Now when we were talking about subatomic particles, I'm using a new term here, subatomic particles. What are subatomic particles? Particles that are inside atom, inside the atom. Okay, and these are again protons, neutrons and electrons. When we were talking about subatomic particles, I said atomic number, we discussed that atomic number is equal to number of protons, which is also equal to number of electrons. That is the case of neutral atoms, where atoms do not have, we're just talking about elements in regular. But remember, protons are characteristics and they are unique to elements, right? And you cannot remove a proton or a proton and keep the element same. If you remove the protons, you have changed the element. Electrons, on the other hand, can be removed, okay, for the purpose of chemical reactions. You can rearrange electrons. Now in that case, what happens when you add or remove electrons? You now have is an ion. When you add or remove electrons from an atom, ion results. So ion comes from adding or removing electron. So what's happening here? If there are, say, let's talk about sodium, for example. Sodium has 11 electrons and 11 protons. Now what you can do, you can remove one electron from sodium. So you take sodium and then you remove one electron, get one electron out of there. What you get is a sodium ion. This signifies that one electron has been removed, and the positive is coming there because you removed a negative charge. The positive is coming there because you removed a negative charge. Now you take chlorine, neutral atom, and then to that chlorine, if you add an electron, what you get is a chloride ion. Now the 1 indicates that one electron has been involved, and the negative indicates that to the neutral atom of chlorine an electron has been added. So more electrons you add, you're adding more negative charge. More electrons you are removing, you are increasing the positive charge. It's very important to learn this. Now, positive ions are known as cations and negative ions are known as anions. Okay, metals usually form positive ions, non-metals usually form negative ions. Okay, so take a neutral atom. To that, if you add electrons, I won't say one electron, but to that if you add electrons, any number of electrons, so I will say n number of electrons, what you get is an anion. And if you take a neutral atom, and to that, from there, if you remove any number of electrons, what you get is a cation. Okay? Now, on the periodic table, like I said before, metals form cations. Now, these two groups, metals from these two, they form predictable. So, you know all the group 1A forms +1 ion. That means you can take out only one electron from there. Group 2A, they form +2 ions. You can take out 2 electrons. Now, for transition elements and for a couple of other elements here, and we'll talk about that in detail, you can remove one or more based on the nature of the element and nature of the other element that it is reacting with. So these elements, transition metals, they form ions with varied or variable charges. Okay, they use another term called multiple oxidation states, but we won't talk about that right now. Again, anions, halogens form -1, group 6A form -2, nitrogen -3, aluminum always +3. So these are all predictable ions. So group 1A +1, group 2A +2, group 7A -1, 6A -2, aluminum +3 and nitrogen -3, and you have to remember that. And given a species, so say for example oxygen 16,8 -2. If it was oxygen 16,8, you can tell protons equal to electrons equal to 8, right? But in this case, protons will be 8, but electrons will be different. Electrons will be 8 if it was a neutral element, but you can see that 2 electrons have been added. So electrons will be 10. So given a species, whether it is neutral or charged, whether it has no charge or it is a charged ion, you should be able to tell the number of protons, electrons and neutrons.